I guess we can slowly start. And the people who will late, they will join. They will understand. Hello, everyone. My name is Anton Grishko. I am Chief Architect at prophecylabs.com. And Prophecy Labs is a FinOps platform that helps to minimize costs on the clouds for more than 200 clients all around the globe. If you're interested, please visit the prophecylabs.com website for more information. And let's get back to our webinar. And I want to introduce you our today's speaker, Boaz Ziniman. He's Principal Developer Advocate at Amazon Web Services. And today he will be talking about the modern applications development. Boaz, nice to have you here.
Thank you very much, Anton. Thank you very much, everybody, for joining. Thank you for hosting me. And as Anton says, I'm going to talk about modern application development. We're going to talk about what does it mean exactly in the current environment. Before diving into the topic, let me introduce myself. So my name is Boaz. I'm a developer advocate from AWS coming from Tel Aviv, Israel. I've been part of the AWS team for the last almost 6.5 years, which is a very, very long time. Before joining AWS, I had several R&D roles in Israel, from a developer to running teams to managing development and working with some very cool technical partnerships. And I'm trying to bring my experience before joining Amazon to this role, to this talk. As part of my role as a developer advocate, I'm in charge of the connections between the local community, the local tech community in Israel and AWS. So if you are from Israel, you probably saw me in different events, or maybe read my blog or saw my videos. Here on the slide, you can find all the ways to get in touch with me in terms of following me, check my content. I create a lot of content in Hebrew, so if you're not a Hebrew speaker, you might find it a bit challenging to follow my content. But if you are, I'm creating a lot of content in Hebrew, doing other languages as well, but mainly focusing on the local market. And as I said, today we're going to talk about modern application development and how it looks like today when you're coming to develop a new application from scratch. What are the challenges? What are the things you should be aware of? But before we dive deep into talking about modern applications, let's talk about what does it mean and what do customers want in a real modern application. And there are very, very different things when a customer is coming to design a new application these days. So I've been developing applications, mainly web. I am coming from many years of web development practice, but I've been doing other things as well. And the world changed a lot since I launched the first website, the first commercial website I did somewhere back in probably 99, maybe 2000, I don't remember exactly. And a lot of things changed since. So first of all, the scale. The scale of a modern application today is targeted to millions of users. When we were doing small web or mobile applications 10 years ago, 15 years ago, our scale was maybe in the thousands, maybe tens of thousands. And talking about millions was something that only very large applications, very large corporates were dealing with. And today, with the fact that our system can become viral very, very fast, the fact that a lot of different types of devices and a lot of different types of users are accessing the system, we need to be able to scale to millions, or at least have a roadmap in case we will need to do this scale. Then we're talking about global availability. So global availability is something that is very, very common today. You're usually not designing applications only for a single market. Maybe you're doing it as a internal stage or something in between, but usually this is something you need to take into account. And for global availability, there are all kinds of technical complexities. There are regulations that you need to take into account, even culture-wise, like Hebrew is written from right to left. Most of the other languages, except for Arabic, are written from left to right. And what do you do then? How do you design your application? Where do you store the data? What are the regulations you need to store the data? Of course, many, many things you need to take into account. Response time in milliseconds. I still remember those surveys talking about people people willing to wait for 7 seconds for a page to load? I want to see a single person here. You can vote if you want, or throw tomatoes and be. I don't really care. If you're willing to wait more than 2 seconds for a page to load, so response time is very, very critical, and of course data. The amount of data we're handling today is rapidly growing. It used to be very rare to get to deal with a database that is more than few gigabytes, maybe terabytes. Today, petabytes of data is the standard, not necessarily databases, but a lot of data we need to process. So how do you do that? How do you create those modern applications and take into account all of these things? So there are several things you need to take into account, or you need to provide your developers or have in your environment to be able to develop those modern applications. So first of all, we need a way to have a modular architecture. And for that, we have all kinds of patterns. We're going to talk about them, how to create architectural patterns that will support modern applications and modular services. Then we have everything related to the operational model. How do I manage these applications, these very high throughput, fast distributed applications? There are some challenges associated with that you should take into account. Then you have the software delivery. How do you make this entire process end-to-end of writing software, testing software, deploying software, maintaining it, improving it? How do you close this entire circle, and how do you make it as automated as possible? There is management and governance, super important, because everybody are responsible. Your developer needs to take into account things that, as a developer, 15 years ago, I was not even thinking about, like security, like many other things, speed, response time, things like that. Everybody are responsible. How do you create a framework for that? And of course, data management. I have a complete separate talk, 45 minutes talk only about purpose-built databases and how do you choose the right database for a specific task, especially with modern applications, but we're not going to talk about it today. We are going to focus on the first three. We are going to focus on the architectural patterns, on the operational model, and the software delivery part of modern applications. When the end game, the aim of everything we're doing here is to deliver rapid innovation, to create better application, and this is what we will try to achieve with using modern application development. So let's start talking about the different components. So as I said before, we're going to focus on three things. First, we're going to talk about architecture patterns. How do you build an architecture that can support modern application these days? Then we're going to talk about operational model. We're going to focus on serverless, although it's not the only operational model for modern architecture. There are others, but we are going to focus on serverless. I'm going to talk about the reasons for that later on. And eventually we will finish with software delivery and everything related to software release velocity. I will try to do a demo, a live demo. So hopefully everything will work and there will be no surprises, but with live demos, there are always surprises. So let's see how it's worked for me. Anyway, we'll get to it a bit later. So moving on, let's start with the first thing and talk about the changes in architectural patterns. So as I said, I've been developing software for many years, and most of the software I developed most of my career, and to be honest, most of the software that is still running in production is designed as a monolith. So basically the idea of monolith says that you have one piece of software, one big piece of software that does everything. All the components of your applications are part of this monolith, and it has to work together. And we see a shift to microservices, which we are going to describe in a few minutes. But you have to remember that many of the software that were designed in the last 10, 20, even 30 years were written as monoliths. And actually running monoliths has some very interesting challenges. So they are good, they're doing their job, they did their job for many years, but there are some limitations. There are things you need to take into account. First of all, there is a lot of coordination needed to make sure your monolith is actually working. So if you have multiple teams working on different parts of this monolith, eventually you will invest a lot of time in coordinating the connection between the teams, making sure that the entire software can work together. And this is a lot of effort. In many cases, it will slow you down, and you will invest a lot more time in coordination than on innovation, and this is a very big challenge. Then you have the challenge of modularity. A monolith can usually be changed or be delivered in a single unit. And you can't really break a piece of it and invest a lot of time in this piece and invest a lot of effort and make it work faster or use newer technology. You usually need to take into account a lot of moving things around how your monolith is working. Every change is important. Every change is big. Every change is taking a lot of time. I don't know how many of you develop monoliths or still in a team developing monoliths, but when you have, you need to do a change, it will take you usually weeks. Even if you have a security issue that you need to fix right here, right now, it still will take time because the process is long, because every small change you're doing, you need to check the entire system, the integrity, and make sure that nothing is affecting other parts. Scalability is really, really a challenge. So we are going to use a lot of the example of an online store. And in online store, you have different components. You have the catalog, and you have the shopping cart and the checkout process and many, many other parts. Most of your customers will go to the catalog, and you need to be able to scale the catalog really, really fast. This is what we're doing at Amazon. But in a monolith, and Amazon used to be a monolith, we're going to talk about it a bit more later on. In a monolith, you can scale only the entire monolith. So you can't only scale parts that need more scaling, like the catalog, maybe your shopping cart, and leave the checkout process with only few users reaching it in a different scaling policy. And of course, very long cycles, very long build times. I still remember that when we were building our monoliths, we usually were trying to time it around lunchtime. So we will start the build, go to lunch, come back, find out that it's still building, play a few rounds of snooker, have a coffee, and then hopefully get a working version. And this is not a very long time for build. In Amazon, the Java application that ran Amazon in the beginning, before we moved to microservices, took about 24 hours to build. So just think about it, like 24 hours, you're basically just waiting for your product to be ready. And then there are the reasons why to move to microservices, and a lot of things that you are solving, that you are changing by doing this move. And this is why we see this becoming very, very popular for many, many cases. First of all, you have the option to pick the right tool for the job. With microservices, when you're breaking this monolith into small pieces, you can actually decide that this piece will work with Java because this is the best option for this one, and another piece will work with another language, which is completely different, because this is what you need. If you want to choose Rust, if you want to choose Go or Node.js or something similar, you have the ability to do that. Same for databases, so you can be really, really granular with the technology you choose for your different use case. It will improve the resilience and security of your application because you can actually dive deep into the exact needs of a specific service in terms of security and resilience, and not have a common solution for all the different parts of your application. You can do a much better granular scaling. You can scale only parts of your system. You can scale one environment. You can scale several Lambda functions or containers based on the exact needs of your customers. It will lower your cost and make your application perform faster. You can optimize your productivity and your team productivity because you're working on small chunks of your application. You can put more manpower on a specific challenge or a specific product. You can create new compositions early and easily. Much easier to introduce new features instead of trying to plug them into some existing monolith architecture. You can experiment and fail safely, relatively safely. Think about it, if one service is failing in a system that consists of hundreds or maybe even thousands or tens of thousands of services, usually the blast radius, this is how we call it, is going to be small. When you have a problem in your monolith, something failing in your monolith, you're usually creating a very large blast radius. You can adopt technologies much faster. Like you could say, okay, all new projects are going to use this new cool technology, and start working with this to see how it works for you. And you can deploy features safely and quickly. At Amazon, we deploy 6 times every second across the entire company of new features and improvement for the different microservices we are running in production. So this is something you should take into account. And usually there is a very big challenge to move. So today, if you're writing new software, many will choose microservices, although some will choose monoliths as well because of different reasons. But the big challenge is the move. How do you move a monolith into microservices? How do you do that? We won't dive too deep into this, but in general, this is a very big challenge which needs to be planned, and it's super important. One of the patterns I really like is the strangler pattern. Basically, to take a monolith and start breaking it piece by piece, chunk by chunk, and move parts of it into microservices architecture, and actually create a situation when both your old monolith and your new microservices are coexist, and just routing the traffic based on the different parts of the system, until eventually you are strangling the monolith, and then it's going to become obsolete. I know some cases when most of the functionality was moved away from the monolith into a microservices architecture, and the company is still keeping the monolith for some legacy old usage that they know they're going to get rid of at some point, but they don't see the real need to do it right now. So definitely another option for you to consider. Where do you want to be in terms of this process if you're doing this migration? Let's show you an example of microservices architecture. So I'll go back to my online store example earlier, which works really good with me coming from Amazon. So we've been doing this for many, many years. We've been doing this with monoliths, as I said before. And at some point, Amazon decided to break the monolith and move into microservices. So a very high-level basic architecture will look something like that. You have a client that is calling a load balancer. This load balancer can route the traffic to the different components, and everything that the end customer will reach and will have interaction with is in a group of services called the storefront UI. This storefront UI will include probably hundreds and maybe even thousands of services that will give the entire experience to the customer. But the storefront UI can work on its own. It needs data, it needs databases, it needs all kinds of other systems. So there is another layer of systems. One of them is dealing with accounts, the other one is dealing with shipments, third one will deal with inventory. And each time I need to get information, like for example, if I need to log into my account from the storefront UI, there is a service in the storefront UI that will talk to another service in accounts, which will talk to another service that has actually access to the database. And this is what I was talking about security. You can secure the access to your database to a single service that has only read permissions from your database, for example. And there is no way to connect directly from storefront UI or even from the service that is the storefront UI is calling. So you can have a lot of granularity in terms of defining it. You have different databases. Each one of them can be completely different technology based on your needs, based on scale, size, speed, and many, many other things. And this is how it works. So if I need something from accounts, I'm going to call service in the accounts family. If I need to create a new shipment address, I will call another service in shipment. And if I just bought a product and I need to remove it from the inventory, the storefront UI will tell the inventory services that this product is no longer available, and some magical process in the backend will update the inventory for me. And this is a very common and high-level architecture for microservices. And one of the advantages of something like this is that it's really, really easy to scale. So for example, if we now want to introduce new features like a mobile app or IoT devices, I'll talk about in a second, it's actually most of the components you need are already there. So you are introducing an API gateway for your other devices. It can call other services. And then the operation of logging or creating a shipment or removing something from the inventory is exactly the same thing. So you just need to route those requests to the right place, maybe create some additional services, like I have storefront UI, maybe I'm going to have a mobile UI family of microservices. But in general, this is something that can be done relatively easily than adding this functionality into a monolith. I want to use this IoT example because I think it's a cool one. So if you are an online store with virtual existence only, and then suddenly you open physical stores, and you want your inventory system to be connected to your between the physical and the virtual stores, and you can place IoT sensors on your inside your physical store, and each time somebody is removing an item from a shelf and not putting it back, so you just calling an API that will update inventory and remove one item from your inventory for this specific item, and then it will automatically update everything in Storefront UI, your mobile app, and this is how you close the entire cycle of having a physical store for a virtual online store, which can be very, very interesting. And once again, everything is there to do that. All the plumbing is there. You just need to create the interface to be able to start working with this. Obviously, you need glue for that. You need to connect all the parts together. So APIs are the glue of modern microservices architecture. They usually are the front door to access your system. Services will talk between each other in APIs or in some other ways. And API is becoming a challenge that you should take into account. And API Gateway, which is a service of AWS, will allow you to manage your APIs with a lot of very interesting features from global distribution to security to authentication, connection to different services behind the scene. And we have customers running very large scale operations, microservices operations, using API Gateway as the front door for everything they're doing. Another very important architecture that is taking more and more focus in the modern application development is everything related to event-driven. So I don't know if you saw the latest keynote from Werner Vogels from re:Invent, our yearly conference in Vegas, but I really like this slide from the event. Werner was talking about the world, that the world is asynchronous. And actually, in many cases, especially with monoliths, we try to create everything in a synchronized way, because a part of the system call another part of the system, call another part of the system, from a function to a class to another class, and so on. And then we were just sitting and waiting. And in most cases, operations are asynchronous. And we don't want our customers to sit and wait for our entire process to finish. If I'll go back to the online store example, after placing an order and after your credit card was approved, I don't want the customer to wait for the entire backend fulfillment process to finish. I don't want it to wait for the inventory to be updated, for the shipment to be created, for the email to the warehouse to be submitted. And in many cases, all systems created everything synchronously, and this is why we were waiting for a very long time in some cases. And we would like to create an architecture which is asynchronous. And for that, today we have all kinds of different services allowing us to break the synchronization between phases. If it's using messaging, a very common pattern, if it's queues or a pub/sub environment, or EventBridge, which is a relatively new service that allows me to create synchronization between different parts of my system using events, or by creating workflows. Workflows are very, very common. Creating a workflow of multiple microservices that can start with a single one and then break into 2-3 parallel ones and go back to another single one based on the results from the previous ones. This is something that we see a lot in building those modern patterns. And as you can see, there are a lot of different services to create this glue between your microservices. So client to server, messaging, and orchestration, each one of them is basically something you can use to create the glue between your different services. And eventually, the modern application would look something like this. A lot of small pieces loosely joined, as opposed to monoliths where they are really, really coupled together, creating an architecture that is very, very scalable, very light, and includes a lot of different services. And as you can see, there are no servers here. I call it services instead of servers, a very important pattern if you want to follow and if you want to create an architecture that can scale really, really fast. With that said, we have to remember that microservices are better for many, many cases, but there are challenges associated with that. And some of the reasons why people are still using other architectures are because we have a lot of more moving parts. I said before, today in Amazon, we run tens of thousands of services. And this is a very big challenge, and we should take it into account. The integration between the different services is a very big priority. Deployment, monitoring, security needs to evolve. We can't use the same techniques we used before. I'm going to touch it in the last part of this talk. And this is not only a technical change, and this is something you have to remember. Moving to a new way to design your applications, if it's using DevOps or SREs, or changing the way you deploy, build your teams, working with the system require organizational and cultural changes. This is not only a technical change, and organizations that neglect this part in many cases will struggle. So I really make sure that this is something I talk about, and this is something you should take into account. Now, to try and overcome some of these challenges, we will move to the next part and talk about the changes to the operational model. So basically, if we will keep the same operational model as before, servers, routers, storages, managing all of them by myself, it would be an additional challenge, an additional task I have to do when dealing with modern applications. And we see a very interesting shift to a slightly different operational model. So let's talk a bit about the scope of options, and scope is really, really wide. So running your application on AWS can be done in many, many different ways, using many different tools. And basically, you can run anything between, go all the way to the left on your servers on premises in your own data center, to all the way to the right into a complete serverless architecture. And then there is a lot in between. You can run virtual machines on AWS, full control, you can do whatever you want, but you're in charge of most of the components. You can go to the right and decide running serverless when you provide us only the code. We're going to talk about it in a second. When you want to run your microservices architecture on AWS, you basically have this, this diagram talking about your different options. Going from the bottom, EC2, a virtual machine, deploy your microservices on this machine. You are going to get full control of your application. You can do whatever you want. You can install any software you want. You have full control, but this is something you'll have to manage. So you're taking a lot more on yourself. Then moving up the stack, you can deploy your microservices with containers. There are several ways to do it on AWS. You can work with ECS, EKS. Those are two ways to control or to manage your containers environment. ECS is the Amazon proprietary one. EKS is based on Kubernetes, a very popular way to orchestrate and manage containers. And by doing that, you are moving part of this management to AWS. We will do the orchestration control plan, the physical hardware we will manage for your networking, and many, many other things. So you're doing less. Moving up, you have AWS Fargate, which is a serverless way to run containers. You don't even need to run the infrastructure to host your containers. And the top level, what we're going to focus a lot in this part of the talk, is basically using AWS Lambda. Where AWS Lambda, you provide the code only, and we will do everything for you to run this code as needed. So your service can be a single piece of code, a function that you will deliver to us, and each time you're going to need it to run, it will run for you. So let me explain what is serverless for those that are not familiar with this technology. So with serverless, you have no infrastructure to provision or manage. There are no servers whatsoever. You don't have access to any servers. It will automatically scale based on your application needs. You will pay only for the usage of the compute environment to run your code, and high availability and security are built into this technology. And you need to do very little to make your application high available and secure. How it works? So it's an event-driven technology. There is an event, something that happens somewhere on the system. It can be an API call. It can be writing a file into an S3 bucket. It could be a change in your database, or an event coming to EventBridge or to SQS. And there are all kinds of events, and Lambda supports dozens of them. And each time there is an event, your code will wake up, will run, process the event, and basically die. And you will pay only for what's running right now and for the time. And this is something that will allow you to scale really, really fast, build systems, build microservices much, much faster. And this is something we see becoming super, super popular. We have hundreds of thousands of customers running Lambda in production with trillions of invocations of Lambda functions every day. And this is something we see growing really, really fast. There are a lot of really big projects. If you're interested to hear more about one of them, check on YouTube for This Is My Architecture video about Nielsen processing 55 terabytes of data daily. This is a video I did about 2.5 years ago with Nielsen Media about how they process 55 terabytes of data with serverless, with no servers whatsoever. Super interesting. So if you want to dive deep into more into those examples, this is a great one. But you have to remember that serverless is not only functions. Serverless is a state of mind, is a way of thinking how to design your architecture without using servers or with reducing the number of servers. And there are a lot of different services at AWS that are acting as serverless components. For example, S3 buckets, storage buckets are completely serverless. You just roll data to store there, and it will store for you. It will scale as needed. You don't need to do anything with it. You have options for databases that are running in serverless mode. If it's Amazon DynamoDB for non-relational databases, or Amazon Aurora for relational databases. You have tools like RDS Proxy that will allow you to connect more clients into your databases. You even have an elastic file system that can be attached to your Lambda functions or to your containers to make your storage elastic as needed. And all of this eventually trying to reduce the time you invest in running your infrastructure, in taking care of your infrastructure, updating, securing, working on that, and free your time and your developers' time to do the most important thing, and this is to develop the best product possible they can develop and they can deliver. Before moving to the last part, I see that there are 2 questions in the Q&A. Let me have a short look. Talk on deployment strategy. I will talk on deployment strategy. Where can we get the PPT? The PPT will be shared later on with the team here. I know what are the means to share it, but they will share it with you. Any more questions before we move on? Okay. So the last part I want to talk about is all the changes we are seeing in the delivery of software. And I have to say this is a relatively dramatic part of how it used to be and how it's working today. So if we'll go back to the Amazon story, Amazon used to be a very large monolith that ran Amazon.com until early 2000s, more or less. And then we made a decision that this is something that we can't grow the company with. We can't have the pace of innovation we're looking for, the customer support we're looking for, the service level we're looking for, and decided to break this monolith into multiple microservices. And not only breaking it into multiple microservices, we broke it into a different approach for teams, which we call 2 pizza teams. I won't go too deep into this concept, but the basic idea of two pizza teams is that this team is in charge of a specific service end to end. So in terms of skills, we'll have designers and developers and QA and product people and even support engineers that will take care of a service end to end, and they are the owner and in charge of this service. People can move between 2 pizza teams. They can be in multiple 2 pizza teams. The idea of the name, the 2 pizza team, is to define that the team in Amazon is the size of a team in Amazon is the amount of people that can be fed by 2 large pizzas. It's a number that can be very, very flexible, and this is what we were looking for. And this is actually our way to look at DevOps even before DevOps even existed. And we have a few concepts which are very, very important to us in terms of how we're running those teams. So we were talking about agility. So microservices, two pizza teams are very, very important. We are trying to automate everything. And I got somebody told me that how do you know if your automation is enough or not? The amount of time you're using SSH to access your servers. You need to come to zero. If you're still using any means to actually go access your server, do manual changes, you still need to work on your automation. We have a lot of standard tools that we're using, not to reinvent the wheel. So a lot of these tools are becoming eventually AWS services that others can use to design their microservices. For example, SQS, one of the first services we launched, was actually a tool that created internally, and a lot of teams used it and duplicated the code. Instead of that, we just created a service in AWS and teams can use it. We have a very interesting concept called belts and suspenders. So belts and suspenders are usually used in the real world for you not to lose your pens. And this is exactly what we're trying to do here. We're creating templates and governance rules to make sure that people won't do mistakes. I'll give you the most basic example. If you're familiar with S3, you can open a bucket. You can define this bucket to be a public one. What happens in Amazon, if I do it on my work account, is that immediately there is a severity 3 ticket being cut for me because I did that. And unless I react to this ticket really, really fast, it will escalate to number 2, and I don't want to have a severity 2 ticket in our system. And this is done to make sure that we are not doing this mistake of creating a public bucket. There is a process, there is a template, a way to white label public S3 buckets. If I need it, I need to fill a form and explain why am I doing that. But in general, for me, not to lose my pens, not to embarrass myself, the company, or anybody else, the belts and suspenders are making sure that I'm safe and I'm not doing mistakes without paying attention. I have some other examples for that, but this is one of them. And of course, moving everything to infrastructure as code, making sure that your entire infrastructure is fully automated and can be deployed by code. And this is something that is super important to be able to deliver this type of modern application running very, very high scale. So talking about the deployment and delivery lifecycle. So this is how it used to look back then. We have many, many developers working with a single delivery pipeline that did all the parts of build, test, and release into a single piece of software called a monolith. Now, we already know that we broke this monolith into multiple services, and we broke this monolith and we broke the teams into those 2 pizza teams of developers attached to a specific service. What happened to the delivery pipeline? And this is a very big question, very important one. And eventually what we see today is basically the same deconstruction we had with monolith services and teams happening with delivery pipelines. We are creating standalone delivery pipelines for every service. And that's a huge advantage for development teams because each pipeline now is completely separate. First of all, it allows you to use different tools. So you don't have to use the same tools as everybody. You want to use Jenkins for your process, great. You want to use AWS Code Pipeline, this is great as well. You want to have one language or the other, use another database, a lot of flexibility that was not really, really possible. And eventually, by doing that, we are getting into the point when this automation will increase your product quality and your developer productivity. And this is something we're constantly looking for to make sure that the product is as good as possible and your developers are as productive as possible and not wasting time. And this is something that we are trying to achieve in a lot of our customers. We have a lot of different tools in our tool pack of AWS for deployment, for managing your code, for software delivery, from authoring the code with Cloud9 to storing your source with code commit or code artifact for containers. We have build tools and test tools and deployment tools and monitoring. We're going to talk about them later on. And I actually want to try a demo on you, if you don't mind, and show you a very simple application that I created and how I can use those deployment tools to actually be able to deploy them and play some very interesting tricks. For that, I need to change the sharing. Hopefully nothing will break. Give me 1 second. I need this desktop. I think I need this desktop. Let's see. So hopefully you can still see my desktop. You see a browser with the message, hello, London? Somebody say yes. Okay, I would assume yes. If not, write something on the chat or in the Q&A. So this is a very simple application that gets a few parameters in the query string. The important one is the message. So I can change the message to a message in any language. It doesn't matter what I'm writing here. What's important is for the application to detect the language. And based on the language of the message, it will print out this hello London message submitted via API. The message is the same, but if I'm running hola, which is in Spanish, the return message hopefully will be in Spanish. If I'm going to write it in Hebrew, the return message will be in Hebrew, and so on. Now, super simple application, but there is a very, very big problem with this application. And I don't know if you guessed it or not, but I'm not in London. I'm in Tel Aviv. And I would like to fix it. And I would like to redeploy this application and to make sure that it's correct and it says hello Tel Aviv and not hello London. For that, I need to manipulate my code. So let me go to VS Code and I'll enlarge it a bit so you can see it. So this is my template that is used to deploy the application. It's used to define and deploy my application. In this case, there are all the definitions of the different functions, the deployment, and so on. And here there is a environment variable that basically includes the message. So, and this environment variable says hello London. I'm going to change it to hello Tel Aviv. And I'm going to save it. Before we go and actually commit it, I want to show you a few other things. It has a deployment definition, this entire application. And in this case, the deployment definition says that the preferences for the deployment is to do a linear deployment 10% every 1 minute. Well, it means that when I'm going to deploy this code, instead of switching to the new version at once, it will switch 10% of the traffic to the new version. And if everything is okay and there is no automatic rollback, every 1 minute it will add another 10%. So eventually after 10 minutes, all the traffic will go to the new version. But until then, only 1 out of 10 and then 2 out of 10 and so on will be moved to this new version. And this way I can have much safer deployment. I can have all kinds of test scripts and test mechanisms, or even QA people going into the new deployment, checking to see if there are problems. If there are problems, very, very easy to roll back. And this is what we were talking earlier about reducing the blast radius. So the blast radius will be very, very small. Only 10% of the users will be affected by this deployment, unless I'm stopping it, and then it's going to be rolled back. So let's see how the pipeline looks like. So to do the deployment, I'm using a service from AWS called the Code Pipeline. Code Pipeline is an orchestration tool. It uses different services like reading source and doing deployments with code build and code deploy and many, many others. But this is the orchestration of the service. The service is based on a trigger coming from GitHub. So this source phase is basically listening to a GitHub repository. I can actually open it, and you can actually get the code if you want to play with it later on. So this GitHub repository is the one that my pipeline is looking at. You can see that the last commit here is 48 minutes ago. I was just playing with it before the session. And now, if I'll go to my console and commit the code, let's do that. Let's do, instead of London calling, we'll do a commit moving to Tel Aviv. And do git push. What will happen here after the push? It will catch that there is a new version, hopefully, a live demo. Yeah, I'm counting on that. Yes. So as you can see, now the source change, it will pull the source and it will send it to the build process. Now, this will take some time, although it's a very simple application, but it will have to bring a build server, we'll have to install everything on the build server and so on. There are build scripts, very simple ones here, but it can be very, very complicated. It will take about 5 minutes, so I won't make you waiting the 5 minutes. I'm gonna keep talking about the slides and then we'll go back and see what happens here. But hopefully when we'll finish, we will move from London to Tel Aviv, but let's see how it works. Let's give it some time. Now it's in the build. Let's go back to the slides, move on with the deck, and then we'll be able to talk about the changes in the application. So the next part I want to talk here is the changes we need to do to improve application performance by increasing observability. And this is a very big challenge. When we had a simple application with basically one log, you need to go to one place to understand what's going on, but it's not the case anymore with thousands of microservices. And today, to get an insight of what's going on, you need to combine metrics with logs, with traces into this new concept of observability, of looking into your application in a much more holistic way. So when we used to have a monolithic architecture, so all your components wrote into the same place. Now your components are completely distributed, and this is becoming challenging to get all the information into one place. And for that, we have special tools and special services for monitoring and tracing. So you can use Amazon CloudWatch, which will take all the logs from your different parts of your application. You can use AWS X-Ray, which is an observability tool, tracing tool that will look into your application and will provide you a lot of information about what's going on inside your application. And you can use a lot of third-party tools that actually were designed specifically to solve this challenge. There are a lot of Israeli companies looking into this specifically for serverless, for other applications. And of course, so we have a lot of different partners providing this type of service and this type of information. Let's see what's going on with our deployment. If we move to the next stage, if not, we're still in the build. Are we still in the build? Stuck? Yeah, we're still in the build phase. So we'll give it a bit more time. It's only 2 minutes, so that's okay. I want to give a few examples of customers that did this change and moved to modern application development. And I actually want to use some legacy enterprise companies instead of talking about a hot startup that started with microservices. So FINRA is a financial company. FINRA scans transactions in the stock market to find all kinds of threats and fraud and many other things. And because it operates during trading hours, the graph of FINRA, the compute usage is very unique. They basically have a very big peak during trade hours. They have almost zero traffic, or really zero traffic when the trade is over. And what they used to do is to invest a lot in terms of manpower and technology to make sure that the scaling of their system is as accurate as possible for the specific load they need. And because it changes on a daily basis, like more transactions, less transactions, all kinds of events in the market, they had a lot of challenges with that. And they actually moved to serverless to improve the processing time of the application by 67% and reduce the cost by 50% by moving to serverless technology instead of running EC2 servers. And once again, this is something that worked really nice for them. Another great example is Capital One. Capital One is a banking company, and they took the concept of modern application development of DevOps to the extreme, actually automating everything, using infrastructure as code and many other things. And by that, they reduce the time taken to deploy a new application by 99%. This is basically changing from weeks to hours. And this is something that gives them a lot of advantage when comparing them to other organizations in this field. And let's go back. How are we doing? Yeah, we're done with the build. Cool. So we're done with the build. We're now with the deploy stage. So actually, I want to show you the deploy stage. Let's see if I can find this specific deployment. Yeah. So you can see that I have a deployment in progress. If I'll go into this deployment, you can see that already 50. Yeah. So we are in 50% traffic shifting. So 50% of the traffic went already to the new application. I think the build ended up much earlier than I thought. This is Hello London. If I'm going to refresh it, every other call should get me to Tel Aviv. Why every other call? Because only 50% of the traffic is going to the new one. So let's refresh it. And I'm still in London. Let's refresh it again. And hello Tel Aviv. Now that's I must say I've been lucky, so exactly 50%. But when you do refresh, you might get different results. I'm back in London, refreshing again, still in London, doing it again, still in London. Eventually, I'll fall on Tel Aviv. But once again, this is statistically. So in general, at this stage, let's see what's the number right now. Yeah, I'm. Something is not accurate here in the traffic shifting. I don't know why. Let me refresh that. Maybe I'm not looking at the right one. Yeah, still everything that was the pre-deployment validation. It's just now starting to shift traffic. So now everything will go to London until I'm going to get 10% going to Tel Aviv. So pre-shifting ended. It did the test for this stage. Now it's actually putting real traffic to the new app. Well, give me at least 10% so I can show something. If I have another deployment, no, still this one. As you can see, I can stop this deployment. I can stop and roll back the deployment very, very easily if I find any issues. And I can actually write scripts that will automatically plug into the deployment process. And we do the rollback for me automatically. I don't know why it's still stuck on 100% on original. Okay, we'll give it another chance at the end. I just have 2 more slides, or actually 3 more slides. So let's finish them first. So few things you should know or take into account when taking this approach of moving to modern application architecture or modern application development. There are some very common questions we hear from our customers. How can I move my workloads to the cloud? How can I use these advantages of modernizing applications? And many customers are sharing a lot of these challenges, sharing the same challenges. And it's a process that you need to plan. You need to take into account that it's not like doing like this and you moving from monolithic architecture into microservices or into modern application. And you need to be ready for this change. You need to prepare your teams, train your teams, get the tools, and of course, consult with us, with our partners, how to do it the best way possible. And as we mentioned during this talk, architecture, operational model, and automation are very important building blocks in this entire process that will allow you eventually to get all the benefits of modern application, from better performance, reliability of your application, much better connectivity to your exact business need, developer productivity, much shorter time to market, increase your revenue eventually, and lower your operational cost if you're doing it correctly. Before we wrap up, and I'll go to check some questions. I see I have 10. I don't know if we have time for 10. Yeah, as you can see now, I have 60-40 split between traffic. So hello, London. Still in London, and now I'm Tel Aviv. So you can see that it's shifting traffic from part to part based on based on this traffic shifting policy. Eventually, after 10 minutes, I'm going to be 100%, and my application is going to be fully deployed, and all the customers are going to get to the new one. So that's what I wanted to share with you today. Thank you very, very much for listening. I see we have few questions. We have about 4 minutes. I'll try to go through them, provide some answers. If not, these are the ways. I can see the Q&A, so I'm going to move it here so it won't be on your way. These are my contact details. Feel free to contact me, LinkedIn, Twitter, if you want to follow up, ask more questions. Let me have a look at the questions. Could you elaborate on service mesh? Not right now. That's a very big topic to do it in just a few minutes. Of course, any comments about Prime Case a few days ago. So if you're not familiar with the blog post from the Amazon Prime Video team, they moved one of their applications back into monolith because this is something that solved the problem. As I said during this talk, you need to choose the right tool for the job. Microservices are not a silver bullet. They won't solve all your problems, but making a decision when you know exactly what you're looking for and knowing your options is very, very important. So my comment is look for the right tool for the job. It's not always serverless. It's not always containers. It's not always monoliths or microservices. For every challenge, there is a solution. The Amazon Prime Video choose to pick a specific solution for one of the challenges. They have many, many others. They're still using microservices, still using serverless in many, many other places. So if you did not read this post and everything that happened after it, look online. Thank you for the comment, George. Happy you enjoyed it. Any more questions I missed? There is a question for Shlomi. Does it mean that there will be a minute where different users will get different answers? The answer is yes. As you saw it, it's up to you. You can decide how to do that. You can have all at once deployment if this is something you can afford, or this specific service is not a good fit for that. In my case, this is just a message, so I'm fine with it that some users will get a different message, but it's completely up to you. It's something that you can define in your deployment strategy. And Wojciech recently saw a video that talk about. Yeah, I think I talk about the monolith architecture. Once again, this is a very specific topic, and you can find more information about it all over the internet. I don't know about the comment about the ingress control. I don't know what the question here is, and let me see if I missed anything else. No, I think we're good. Anybody else that wanted to ask something and I did not talk about it? Okay, we are at the top of the hour. Thank you very much for joining. More than welcome to follow me, Twitter, LinkedIn, GitHub. If you want to get the code of this presentation, of this demo, you're more than welcome to do that and use it on your own. Thank you very much for joining.